Today in this video, we are going to study about the bloom filters. So first of all, let's understand what is the actual problem. So if you take an example of Instagram, Gmail or Twitter, first of all, what you are going to do, you are going to type your username, and whenever you are going to type your username, it will tell you that this username is already existed or not. So for example, if I type this username here in the Instagram, it will tell you that this username is already taken. Okay, so it will give you some kind of response, or it will tell you to make a new username because this username is already taken. And this thing is doing by Gmail, Insta and Twitter, or maybe with the Spotify also. I can give you one more example. Let's say that if you want to type a song, and this song we have to search into any playlist, then what the Spotify will do in that case, it will just check all your playlist and it will tell you that this song exists or not. So it is going to give you a boolean value that this song exists or this song not exists. So this is the case, and these companies, basically Spotify, Gmail, Instagram, Twitter, these companies doing this thing very fast. So they are solving this problem with the help of bloom filter. The one solution that can come to your mind is that simply go to the database, search a string, and let's say give back the response. But at the billions of records, when you are going to have the billions of records, this thing will not work. You have to come up with any smart solution. So the smart solution is going to be bloom filters. So let's talk about what are the bloom filters now. So first of all, let me tell you the definition. So the bloom filter is a probabilistic data structure in which there are two rules. Let me just tell you with one simple example. So suppose we are going to talk about this particular example, that there is going to be a user who is going to type a username, or if you're taking an example of Spotify, you can type a song. So let's take an example of a username. So let's say if I put @savage. Now this bloom filter, whatever the algorithm is, we are going to discuss it. But think of it, bloom filter will respond you with two things, either yes or either no. So let's say we pass this string to the bloom filter. We pass to the bloom filter, and let's say if the bloom filter return no. If it is going to return no, then what is going to happen? It means that this particular string is not exist into the database. If it is going to return no, it means that it is not into the database. You can directly make the save call to the database. Basically, you can make this username. But now what is going to happen? If it is going to return yes, it means that maybe it can be into the database and maybe it cannot be into the database. That is why we call bloom filter as a probabilistic data structure. Okay, so I'll just repeat it one more time. If the bloom filter is returning no, it is making sure, okay, that it is not going to be present into the database. It is definitely sure that it is not into the database. That is the power of bloom filter. But if it is going to return yes, in that case, it may be present into the data. This is the whole thing. Okay, that is why we call it the probabilistic data structure. What is the purpose of it? The purpose is simple, that if we pass into the bloom filter, we are going to save a lot of read calls. If the user is going to send the request to the bloom filter, we are not checking into the database directly. And think of it, in 99% of the case, let's say if we make the situation in 99% of the case, if we are going to get the no, then we save lot of read requests. Okay, and let's say 1% case, if the yes is coming, then only very less time we are checking into the database. Previously, if we are directly connected to the database, then 100% of the time we are checking into the data. So this is the problem that bloom filter is solving. I hope I'm able to make you understand this point. Now let's understand what is the algorithm inside this bloom filter, how it is returning yes or no. Let's understand it. So let's talk about how it actually works. So first of all, let me just take you one example, that let's say if I pass this username savage. Okay, bloom filter will have one array. So I'll make one array, and in this array, what we are going to do, I'll just write the indexes 1 0 1 2 3 4 5 6. Okay, so these are the indexes that are going to be in the array. Array is going to be very long and like very big in the size. In the actual production case, I'm just taking a very small array. Now what we are going to do, I'm going to pass savage into this particular array. Okay, this is going to be a bit array, and now we are going to use the concept of hashing. In bloom filters, we are going to use multiple hashes. So there are going to be multiple hash functions, and these hash functions are going to return some particular value that we are going to fill into this bit array. So for example, what I'll do is, this is the savage, and now what I'll do is I'll just pass it into multiple hash functions, this particular. So let's say hash 1, and if I pass savage, and it will going to give you, let's say 1 2. Okay, now let's say if I pass it again. Okay, so this is hash 2, this is hash 3, and this is hash 4, and all these hash functions are going to give some value, let's say 5, let's say 7, and let's say 9. Okay, so these are the values these hash functions are returning. So whenever we are going to put this value into the bit array, then our Bloom filter array will look like 0. For at the 0, and the 2th index we are going to put 1, because this hash 1 is going to return the index 2. Again 0, 0, 1, 0, 1, 0, and 1. So this is how my array is looking right now. This is my Bloom filter array. Now let's say what is going to happen if now we are going to get one more entry, let's say Roger. So what we are going to do, I'll just make one more entry of Roger. So instead of this Roger, and let's say if I go Roger and 2, 5, let's say let's go with 2, 3, 6, and 8. Okay, so this is for the Roger. Now the previously, and this is going, let's say I'll just mark it as, let's say when first entry come. Now another entry is going to come, another entry of the Roger. This is the current state of my Bloom filter array. Now how my Bloom filter array will look. So 0. Now at the again 0. Now it is going to be 1, because for the Roger it is 1. For 3th index you will notice there is going to be 1. For again 0, there is nothing on 4, there is nothing on 5, so will 0. There is 6, there is 7, there is going to be 8, and there is going to be 9. So this is how my Bloom filter array will look after Savage and Roger entry. Perfect. So this is how it is looking. Now let's say these two entries are actually going to be stored into the database at the end of the day. Let's say for example the user makes a call, okay, and we are going to put it into the Bloom filter and it is going to be stored into the database. So how my database is going to look like? So if I make a database, so in this database there is going to be an entry of Savage and there is going to be an entry of Roger. Okay, now let's say we take an example if a new person is coming. For an example, let's say if a new person comes, let's say David. Now David wants to check this particular entry, it exists into the database or not. David wants to create a username. Okay, so David is the username and David wants to create an entry into the database. So let's see that person can create it or not. So first of all, we have to pass the David into the hash function. Okay, let's pass it into the hash function. So let's say I'll just copy this David. Okay, now let's say David is getting 1, 3, 4, 5, and 8. Okay, so this is what David is getting. Now, if you will notice, we have to just check into the Bloom filter. So this is my Bloom filter array right now. Okay, so we have to just check that this particular bits are set or not. So this is how the Bloom filter will work now. Okay, so for the David, okay, what we are going to check. So if I copy this indexes here on the top of it, so it is like this, we'll keep it back. Okay, now let's see. For 1, we are getting 0 right now. It means at the starting point only we know that the bit is not set for David word. Okay, for the hash 1, we know that bit is not set. So what we can do is for the David, we can just directly, so basically the Bloom filter in that case will return us no. So Bloom filter will return no for David because any one bit is not set. I think this point is clear to you, because this bit is not set. The first index we are getting 1 for David and this is not set, and directly what we are going to do, we are going to save this value into the database. David also we are going to save into the database, and now we are again going to update the Bloom filter array. So now how will my Bloom filter array will look? Because now we have the 3 entries. So this is my previous Bloom filter array. So now let me just update the Bloom filter array now. So it will look like 0, 1. For 2 it has already existed. 3, 4, we have nothing on 4, so we'll just keep it 0. For 5, we again get 5, 6, 7, 8, and 9. So this is the final stage of Bloom filter array after the 3 entries, Savage, Roger, and David. So we have discussed the case of no also. Now let's see what will happen if we are going to get a yes. In which case we are going to get a yes. Okay, let's say there is new entry coming, let's say of Sam. Okay, I'll just keep it here. Let's say I'll take the entry of Sam. Okay, Sam, and Sam. Okay, so think of it. Previously we get the entry of in the Savage 2579, 2368. Okay, the 2 is the common one. Here 3 and 5, 6 and 8. Okay, so what I can make a pair in the Sam. Let's say if I'm getting, let's say 1, okay, and there is 5, and there is going to be, let's say 8 and 9. If we are going to check this thing into this bit array, this is the final stage of my array. So if I'm going to check it here, you will notice 1 is also marked, 5 is also marked, 6 is also marked, 8 is also marked, and 9 is also marked. So in this case, it will think that all the bits are already occupied, because it is, in the case of Sam, it is already thinking all the bits. You will notice that at the 5th location we are getting 1, at the location of 8 we are getting 1, at the location of 9 we are getting 1. So now we know that maybe it can exist into the database. Okay, so it is not sure. Please, Bloom filter not give the complete surety in that case. So in that case, Bloom filter will return you yes. Bloom filter will return yes, and now you have to check in database. And when you will check into the database, you will figure it out that Sam doesn't exist into the database. So you can create an entry of Sam also here. So what you can do, you can create the entry of Sam in that. Okay, but like you in that case, you don't have to update the Bloom filter array because this 1589 are already occupied with the 1 bit. So this is how the Bloom filter array is keep on updating. You have to just update once into this array. Okay, but right now you are seeing that this array is very small. That is why we are getting so much ones, because the array size is currently of 10. But think of it, the array size is going to be of billions. In that case, number of collisions will decrease. And you will get into the scenario that 99% of the time you are going into the no case, into this case, that Bloom filter is going to save lot of DB calls. You will not get into this yes case. And this is what the company wanted to achieve, and that they have achieved now. Okay, now let me just come to one more theory part now, that why are we talking about the Bloom filter? Why we cannot use try, why we cannot use hash maps, and why we cannot databases directly? So the first answer is try. Try works very well with the prefix searches. Try works very well when you have to figure out the next word, or let's say the next statement, let's say next words is going to be, let's say for example, if you want to search pen, okay, you type PE, then it will tell you the pencil options. Okay, so in this case the try is going to work well because it's a tree like structure, and it figure out, like say this is going to be the tree, these are the words that are going to be formed with these two words. Okay, but in the Bloom filter, our use case is to just figure out that this particular thing is going to return true or false. For the Boolean use case, try is not going to work very well. This is the reason for the try. Now let's talk about the hash map. Hash map, we actually have to store the complete string into the hash map, into the Redis or into the cache. That will take a lot of space. And if it is going to take a lot of space, it includes a lot of memory, lot of money, and it is not feasible. Let's say if you are going to spend a lot of money on caching, it is not worth it. Like that's why we cannot use hash map, or let's say caching. Now let's talk about the DB. Why we cannot databases? Of course, in the databases you can implement sharding. Of course, you can implement indexing. There are a lot of things that you can improve the search. But the thing is, it is going to be still an ON operation. Think of it. Let's say you have to search into the database. Secondly, whenever the strings are going to come, you have to match character by character. Okay, then it is again going to take a lot of time. It is going to give you the results into the milliseconds sometime. So it is not a very good approach. That is why we are not using try, hash map, and the databases. We have to come up with this Bloom filter. Now comes to this topic of mathematics. Okay, so I mentioned that what are the companies using. So I mentioned that what is the size of our array, how many false positives you are okay with, basically how many no's and yes you are okay with. So you have to just come up with a constraint. Now what is the size of the bit array, how many hash functions you should use. So this is the formula. I don't want you to go deep into it. You can just I'll provide you this blog. This is on my website. You can go there and read this mathematics there if you want. But the whole point is, I'll give you a real life example. This is the main point that you should understand, that for the 1 billion items, there we are happy with 1% false positive rate. Okay, so this is the important thing. Secondly, I'll give you one more thing. You need roughly 9.6 bits per item, about 1.2 GB total for the whole bit array. Number of hash functions is going to be around 7. So we have taken an example of 4 hash functions here, but let's say for example, now what you can do is, you can have to in a production use case, your bit array size is going to be 1.2 GB. The bits that is going to be occupied by word is approximately 9.6 bits. Let's say the size of a particular username is going to be around 10 bits. Number of hash functions that we are going to make are going to be around 7. So these are the things that maybe Gmail, Instagram, or Twitter are using. So these is just a constraint that I just figured it out. Plus, it is going to save a lot of space. Okay, because Bloom filter is just an array. Think of it as just a 1.2 GB or let's say 2 GB array that is going to be in your machine. So it is not going to take a whole database, not saving the whole entry into a whole string entry into the database. It is not going to happen. It's just an array. Think of it like this. And that is amazing. Now we have discussed everything about the bloom filters. The only things left is how to implement it. Okay, I noticed in a lot of YouTube videos that we have not discussed it, how to actually implement bloom filter in the cases, in the system design, in the production systems. Let's understand it. Let's say if the interview asks you how to implement a bloom filter, you don't know, you are blank about it. You know the theory, but let me tell you the practical examples. So first way to implement a bloom filter is with the help of Redis. But I was saying that we should not use Redis. It is not like that. Redis comes up with a lot of functionalities, and one of them is Redis blooms. So in the Redis blooms, what happen is that suppose a user send a request. Again, user is going to send the username. Then the request will go to the load balancer and it will go to the servers. Let's say there are 3 servers running of the authentication system, in which we are passing the username. We pass the entry here. Let me just take the lasso pointer. Now it will going to the server 2 and the server 1. Now what is going to happen after that is that server will send the request to the Redis bloom. And Redis bloom. In this Redis bloom, everything, this array is already implemented. And Redis bloom come up with this 2 function, bf.add and the bf.exist. So in the add function, you are going to add that particular thing. So it means that Redis bloom will update the particular array. So what I'll do is, so like there is going to be an array that is managed by the Redis bloom. Okay, and bf.add is going to change the values into this particular array that we have discussed it here. This array is going to keep on updating, and this exist function is keep on checking into that array and going to return us yes or no, basically true or false. Okay, so this is the first example of our implementation by which we can implement the bloom filter. Now let's come to the second example. In the option 2, what we can do is we can write the custom code. Basically, it is a simple logic. Basically, you have to make an array, pass it to the, like whenever the username comes, pass it to the hash functions, implement the, change the indexes and write 1 into that particular array. This is what we have to do. It is very simple logic. So what we can do is you can write a custom service, and when you write a custom service, then this is going to be one single service in which there is going to be one particular array. And now if there is going to be one array and in one service everything is, then again that can be a problem of a single point of failure. And there is a network hop also, that you have to, all the servers, let's say there are 100 of servers are running for Instagram, okay, and then they are sending to one service to figure out that this username exists or not. Okay, for small services it can work, of course, because there is only one service. So there can be an example of a common bloom filter service that you can make that can have one single array and that will store every single thing, and it can give you the response. Maybe at scale it will not work, but yeah, there can be this one solution also. Now let's come to the one more solution. Okay, so maybe this solution is not exactly right. Maybe many companies are using this Redis blooms feature, but now let me talk about the option 3 also. In the option 3, what we are going to do, all the services, server 1, server 3 and server 2 are going to manage their own internal array. So every service have their 2 GB array. Let's think, every service have their 1 GB array in their servers. So server 1 have the array, server 3 have the array, and server 2 have the array. Whenever the username send a request, whenever the username, let's say, sends a request, what is going to happen? It will go to the load balancer. Let's say it go to server 2. So it will go and put the bits here as well and check. Let's say again, this array will going to return you yes or no. Similarly, in the server 1 also, it is going to return yes or no. The only thing that we are going to do here is broadcasting with the help of Kafka. So whenever there is going to be a no response, okay, so it means that it is going to be stored into the database. So let's say if I'll make a little modifications here for you, that for example, this bloom filter will return no. Of course, whenever we are going to get a no, it means that it is going to be stored into the database. So I'll write database here. So it means that there is going to be a change into the particular array because the bits are going to be added into the bloom filter. So now what we are going to do, we are going to modify this array, So this is a simple step that in every situation it is going to happen, in Redis bloom also, in this also, and in this one also. The only thing that is changed is that whenever the modification is going to happen, modify this array. The only thing that changes whenever the modification is going to happen, we are going to push that modification, basically a request, to the Kafka also. And now the Kafka will broadcast it into the other servers. So the other arrays will also modify. So this array will also modify and this array will also modify. So now all the three servers have the correct array. So this is how all the three servers will have the correct bit array for the Bloom filter. So this is how the Bloom filters we can implement it with the help of Kafka, with the help of the common service, and with the help of the Redis. So this is all about the topic. And if you want to read this mathematics detail and everything, if you want to read it into a short blog, you can go to my website and you can read this particular blog and everything will be sorted. So thanks for watching me, and we will meet in our next video where we are going to study something amazing. So thank you for watching me, and bye bye and have a good day.